The natural laws of physics always allow the driving energy in a system to flow until equilibrium is reached. Heat leaves the warmer body or the hottest fluid, as long as there is a temperature difference, and will be transferred to the cold medium. A heat exchanger follows this principle in its attempt to reach equalization. The theory of heat transfer from one media to another, or from one fluid to another, is determined by several basic rules. Heat will always be transferred from a hot medium to a cold medium. There must always be a temperature difference between the media. The heat lost by the hot medium is equal to the amount of heat gained by the cold medium, except for losses to the surroundings. A heat exchanger is a piece of equipment that continually transfers heat from one medium to another. Heat exchangers are used in both cooling and heating processes. According to heat transfer mechanisms, heat exchangers can be classified as 1. Direct heat exchanger, where both media are in direct contact with each other. It is taken for granted that the media are not mixed together. An example of this type of heat exchanger is a cooling tower, where water is cooled through direct contact with air. 2. Indirect heat exchanger, where both media are separated by a wall, through which heat is transferred. In this type, heat from a fluid, a liquid or a gas, to pass to a second fluid, another liquid or gas, without the two fluids having to mix together, or come into direct contact. Indirect heat exchangers are available in several main types, example, plate, shell and tube, spiral, etc. There are three primary classifications of heat exchangers, according to their flow arrangement. 1. In parallel flow heat exchangers, the two fluids enter the exchanger at the same end, and travel in parallel to one another to the other side. 2. In counterflow heat exchangers, the fluids enter the exchanger from opposite ends. The countercurrent design is the most efficient, in that it can transfer the most heat. 3. In a cross-flow heat exchanger, the fluids travel roughly perpendicular to one another through the exchanger. According to the function mechanisms, heat exchangers can be classified as 1. Regenerative heat exchangers. A regenerative heat exchanger is one in which the same fluid is both the cooling fluid and the cooled fluid. That is, the hot fluid leaving a system gives up its heat to regenerate or heat up the fluid returning to the system. Regenerative heat exchangers are usually found in high-temperature systems, where a portion of the system's fluid is removed from the main process, and then returned. 2. Non-regenerative heat exchangers. In a non-regenerative heat exchanger, the hot fluid is cooled by fluid from a separate system, and the heat energy removed does not return to the system. There are three primary classifications of heat exchangers, according to their tubes arrangement. 1. Straight tubes heat exchanger. 2. U-tubes heat exchanger. 3. Multi-tubes heat exchanger, helical tubes type. Spiral tubes type. According to the fluid flow passes, heat exchangers can be classified as 1. Single pass heat exchanger. Fluids pass each other once. 2. Multi-pass heat exchanger. Fluids pass each other more than once. Reverses flow in the tubes by use of one or more sets of U-bends in the tubes, or by means of baffle plates located on the shell side of the heat exchanger. Direct fluid back and forth across the tubes to achieve the multi-pass effect. Although heat exchangers come in every shape and size imaginable, according to the heat exchanger construction, the two most common kinds of heat exchanger are the shell and tube type and plate type. In shell and tube heat exchangers, one fluid flows through a set of metal tubes, while the second fluid passes through a sealed shell that surrounds them. Most basic and most common type consists of tubes in a container called a shell. Fluid is separated from the shell side fluid by the tube sheets. Tubes can withstand higher pressures than shell. Support plates act as baffles, directing the flow of fluids. Advantages and disadvantages of shell and tubes heat exchangers. Plate heat exchangers have lots of thin metal plates, with a large surface area. Consists of plates instead of tubes to separate the hot and cold fluids. Fluids alternate between each of the plates. Plates have a large surface area, and provide each of the fluids with an extremely large heat transfer area. Advantages and disadvantages of plate heat exchangers. Heat exchangers find widespread use in power generation, chemical processing, electronics cooling, air conditioning, refrigeration, marine vessels and automotive applications. Common applications on board ship are ventilation and air conditioning, HVAC, system, boiler, condenser, heater, preheater, and cooler, economizer, refrigeration, freshwater generator, air compressor, etc. Fouling of heat exchangers. Fouling in heat exchangers represents a major source of performance degradation. Fouling not only contributes to a decrease in thermal efficiency, but also hydraulic efficiency. The buildup of scale or other deposit increases the overall thermal resistance of the heat exchanger core, which directly reduces the overall thermal efficiency. If buildup of a fouling deposit is significant, it can also increase pressure drop, due to the reduced flow area in the heat exchanger core. The two effects combined can lead to serious performance degradation. In some cases, the degradation in hydraulic performance is greater than the degradation in thermal performance, which required cleaning of the heat exchanger on a regular basis. Fouling of heat exchangers results in a number of ways. The two most common are corrosion and scale buildup. However, depending upon the nature of the fluid, other factors may contribute to fouling.